Alright, in this video I'm going to discuss about 3 cases of asymptotes. Right, case 1. Case 1, you see here m is greater than n. Before that, what is m and n? Okay, so fx here is a function. N is the degree of the numerator, the highest degree of the numerator, and m is the highest degree of denominator. So case 1 here, m greater than n means the degree of denominator is higher. What happened is, when the degree is higher, the vertical asymptote is when denominator is 0. And the horizontal asymptote is when y is 0. So what happened? Okay, so you look at the example here. If we have a function 1 over x plus 1, so the x here, the power is 1, and the numerator do not have x. So this is considered case 1. So where the m is greater, where the denominator's power or denominators is higher than numerator. So this when this happen, it means that the vertical asymptote, the denominator can't be 0. So that makes the vertical asymptote would be -1 for this, and the horizontal asymptote will straight away y equals 0. If we want to relate with domain and range, so this is a domain and range, we can consider all real values, and we can state the x can't be 3, for example, because 3 is where the asymptote happens. And that can also apply for range, where y can be all real value except when y equals 0. That is where the asymptote happens. X equals 3, x equals 0. This is an example of writing domain and range. Okay, so how about case 2? Okay, so this is case 2. Case 2 happen when the degree are equal. So means that degree of numerator is equal with degree of denominator. So for example here, look at this one. When we have a function, for example, both linear, 6x plus 1 divided by 2x minus 3. So the highest power is 1. X power 1 for numerator and x power 1 for denominator. So the quicker way, or the horizontal asymptote, we can get from a coefficient of these two being divided. Coefficient of the x from numerator and denominator, we divide that, 6 divided by 2. That makes our horizontal asymptote y equal 3. Okay, so the vertical asymptote still the same when denominator is 0. So for this case, 2x minus 3 equals 0. From there we get x 3 over 2. That is the vertical asymptote. So now we can find horizontal asymptote and also vertical asymptote. Right, so why we can ignore this? There's a reason why. Because as the x approaches infinity, if you know the concept of asymptote, is when the values is like infinity, those value like 1 or all the digit values here isn't significant. For example, as the value become very large, if we substitute x equal 1000, for example, what will happen is 6000 plus 1, and the denominator will be 2000 minus 2. So that is like more or less will be 6001 divided by what, 1998 here. So when we divide, we somehow will get closer to 3 still. So this is the concept of asymptote, when the value approaches infinity. This one I want to show you when the m equal n. This is also the highest power for numerator is 2 square x square here, and denominator also x square. But if we factorize this, we'll get 2x plus 1 and x minus 2, and denominator is x plus 3, x minus 2 when we factorize them. And so happen we can simplify those. Yeah, when we simplify, what we get is 2x plus 1 divided by x plus 3. And vertical asymptote, so when denominator is 0, so vertical asymptote x negative 3. And horizontal asymptotes we get from, because both n equal m, so we can just divide the coefficient. 2 divided by 1, we get 2. So that is why horizontal asymptote here is 2. But what happened when we cancel it off? The impact is actually at x equal to, that this will be the whole of the graph. Somehow the graph won't touch or won't be plotted at this point. Okay, so below here, so we sketch the graph. We have vertical asymptote -3, so this is the first one. Vertical asymptote, horizontal asymptote is 2. Okay, and then it somehow of course the graph will be this side, and below here, however, it cannot pass through 2. So the graph is like kind of like disconnected at 2 here because of x equal to. Okay, question, why the graph couldn't be up here? Why the graph isn't up here, or the graph isn't below here? Okay, actually at the beginning we don't know which side the graph would be. So what happened is, if we can't use calculator to sketch this, we have the asymptotes, right? We have the hole here, but why the graph isn't here? This is where we should try out the value. We should put the value. So for example here, x is -3. We can try out if x -4. So we put in the function here. Does it like works or not? So you can try out and you can see what you got. Okay, so in the right side here, check where will be the whole x equal to. So we substitute in the simplified here, and we get a 1. That is a coordinate where the graph, the function won't pass through. Okay, quite a lot of things to do. Asymptotes, checking points, and if there's a hole, so that is what you have to check. Alright, the last case is when m less than n. So this is a degree of numerator is higher. For example, like this. Function y equal to x squared minus x plus 1 divided x minus 2. So you see x squared up here, and it's a linear here. Vertical asymptote, no problem, x equal to. Horizontal asymptote, when the numerator higher like this, is non-existent. We do not have horizontal asymptote. We do not have line, horizontal line like this. However, there will be oblique asymptote. How do we find the oblique asymptote? So we need to use long division to find the equation of the asymptote. Maybe I can show a bit here. Long division, still remember how to do that? 2x squared minus x plus 1 by x minus 2. So 2x, so this will be 2x squared minus 4x, and we subtract. So what happened is 3x plus 1 here, so that makes plus 3 up here, and then because of that you will have 3. Okay, so I'm going to continue here. 3x plus 1 and 3x minus 6, and we're going to subtract. I think the x is done. Here will be 7. Okay, so the concern here, the oblique asymptote means there's a what is that, asymptote line, but it isn't horizontal or vertical. It's a slant line, like an equation of straight line. So this one I just highlight here, 2x plus 3 is the asymptote, but it isn't vertical or horizontal. It's a slant line. Then the graph won't be touching that. You can try out this on Desmo, and you can have a look what I mean with this. Okay.